So show of hands here, who's ever had to learn something new that's a little bit different to what they're used to, and their head's got a little bit muddled? Yep, I think we can all relate to that. So this talk is kind of my story, a little bit about how that happened to me. So I'm Luce Carter, I'm a developer advocate at MongoDB, and this is a sort of high-level whistle-stop tour journey that I took to learn this stuff, and maybe you can relate as well. So before we get started kind of talking about the journey that I took, let's kind of take a look back at the journey I took before that point. And so let's have a look at my history of databases. So back in 2009, I started at college doing a vocational IT course. It was like purely IT. And that was when I first started learning about Microsoft SQL. What's it doing? There we go. And then in 2010, I moved to Manchester, went to university, and we started to learn Oracle SQL. And they actually gave us this whole really fat textbook that we had to follow through that taught us about all the joins and how to get started and all that stuff. You know, so still SQL, but again, different type of SQL. Then in 2015, I started work as a graduate software developer at Fujitsu, where we started to learn about different types of SQL again. So that's when I first discovered the open source Postgres SQL, and also SQLite.net, which is their .NET implementation. Funny enough, actually written by a friend of mine, which is really insane to think about. And then in 2017, I moved to work at the BBC, and they use a lot of Amazon Web Services, and including Amazon RDS, or Relational Database System. And so looking back, you know, over all this period of time, you know, what, 7 years? No, I can't count. 8 years. It is all about SQL. You know, as .NET developers, a lot of us, or you know, developers in general, a lot of the time, when you talk about databases, people just think about SQL. And I was exactly the same. In 2021, 1st of June actually, so almost just short of a year ago, I started work as a developer advocate at MongoDB, and it was awesome. And as I say, document databases for the win. But you know, it was a new experience, and so it was my first foray into something that wasn't relational databases. And so you know, that took some getting my head around. As George Bernard Shaw said, progress is impossible without change, and those who cannot change their minds cannot change anything. And that's kind of what happened to me, because full transparency, when I started my job last year at MongoDB, I'd never really used their products, let alone document databases. And so I had to take this journey to kind of get to know it a little bit and be comfortable with document databases. And so, as I say, this talk is just, you know, let's go on a journey together of what I learned along the way. Because, you know, it's fun, and maybe you can learn something from it as well. And so the first thing we're going to cover today, just point it ever works, there we go, is what tables versus documents are. You know, let's do a little bit of term mapping so you understand the differences. Then we'll start to look at, well, out of all the document database options, why MongoDB specifically? Then we'll have a look at, well, .NET with MongoDB. This is an intro to MongoDB and .NET talk, right? Let's actually talk about some .NET. And then we'll look at it a little bit in action, because, you know, be upfront, there are some code samples later, but again, they're just high-level code demos. So we'll actually spend some time looking at some real cool things that are going on. So let's start off with a little bit of document mapping of, you know, tables versus documents. So the first question we kind of have to ask ourselves, right, is what is a document? Well, a document traditionally is a JSON-like document. So if you know JSON from C programming languages like C, C++, C#, Go, PHP, Python, all sorts of them, you know, JSON's not new to you. So it starts off with the curly brackets around the outside, and then you've got your field value pairs. And, you know, sometimes it's called, you know, field value, key value, property value. You know, sometimes the terms change a little bit, but the structure stays the same. But that's all well and good in theory, just saying, oh, you know, it's a document, has some curly brackets and some field values. But let's actually just look at it more practically than just a theory. So I started to think about, okay, what can I do? What kind of, I learn by doing sometimes, right? So I was like, what can I do to help me actually learn this stuff a bit better? So this is me in the gym. I very rarely take pictures in the gym, so I'm quite impressed that this picture exists because it proved quite helpful. But this person stood in the corner is my personal trainer. And when I started at MongoDB, I was thinking, right, okay, what can I, what real world example could I do? And I was like, oh, I'm at the gym. I know. Let's pretend that Phil's got all his information in a relational database, and then go through what would happen if you wanted to migrate it to a document database, just to try and get my head around the differences. And so, this is what I did. I started to sort of theoretically map it all. And so the first thing to think about in a traditional relational database, right, is the clients table. So you've got your, you've got the usual things. You've got your, is there a pointer on this? No. But you've got your, your ID, your unique identifier, and then you've got your name, maybe number of sessions a week, and a phone number so Phil can get hold of you. Pretty standard stuff. But what would that look like in the document database world? Now, MongoDB documents are something called BSON or binary JSON. So it's a JSON that you know and love. It's readable and everything, but it supports a few more data types, and that's quite useful, as we'll see later on. But initially, a document is pretty straightforward. It looks exactly as you'd expect. Direct mapping. You've got an ID, a name, a sessions, and a phone number. But one thing you'll notice here is that you've got underscore ID. And this is, again, a unique identifier in MongoDB, but it's actually a special type called an object ID, which looks a bit like a GUID. So you can specify your own if you like, hence the one, but this is very theoretical. In the real world, it would look something really funky, but it auto generates it for you anyway. But, that's pretty straightforward, but things can start to get more interesting because clients also have goals. So, I don't know if anyone else here has a personal trainer or anything, or if you just go to the gym, often you go because you've got a goal that you want to achieve. It might be, like in my case, want to run 5K, I could do that. Build muscle, I can lift a lot heavier than you think, which is also cool. Complete a pull-up, we're getting there. I was doing some the other day, so that's a start. But, I went with goals of things I wanted to achieve. And so in a relational database world, you start to see it as separate tables. And then you have to have the things in common to map their relations. So in this case, we've got a client ID column in the goals table that then associates it with a client in the clients table. But that's kind of messy, right? As you start to get more more tables, and you've got complex relationships, you start to have to go into this territory of joins. And joins can be quite expensive and quite complicated and quite hard to learn. But at MongoDB, we have this saying, which is data that is accessed together should be stored together. What is the point separating stuff out when, if it's related, just stick it in the same document? So a group of documents in MongoDB is called a collection. So we can have a document in our collection which has all the extra info we need. So the goals as an array, and it's just a string of things we want to achieve. So run 5 kilometers, build muscle, complete a pull-up. But because it's data about that one client, keep it in their single document. There's no need to split it up between different tables. And then, of course, we move on to exercises, because you want to achieve, the way to achieve the goals, you've got to do exercises along the way, right? So that's where exercises come in. And again, you've got the client ID to map it to the other ones, but we're already starting to see it getting a bit disjointed because we've got all multiple tables, and we've got the client ID, and then we've got exercise name, and then the total number of sets and reps you might do, so that you can store what exercises you're doing each week. Because Phil comes with a plan, right? We wing it sometimes because he'll ask me what I fancy doing that day, but on the whole, we will have he'll have a plan. But and this is all there as columns, but technically, none of them mean an awful lot unless they're together. So you'd have to start doing joins just to bring together the exercise name and then the sets and reps. But like I said, in MongoDB, data that's accessed together should be stored together. So we can take advantage of the fact that in MongoDB, because it's binary JSON, it supports arrays and arrays of objects. Or you could argue an object is just an embedded document. So in this case, we've got the exercises, and so we're saying that we've got a bunch of objects that represent each exercise, because on their own, the name, the sets, and the reps mean nothing. How many sets are you doing? How many reps are you doing in that set? What are you doing in those sets and reps? Without a name, it's meaningless. So we just group everything together. Nice and readable, nice and simple, great. But then it might start to get more complicated because, I'm not Phil's only client. Phil's got my friend Chris. Now, she's the reason that I know Phil. But she lives near Phil, and so they tend to bump into each other on a walk, and so if they want to make any plans, they don't need a phone number. And Chris is quite delicate about her privacy, and so doesn't like showing her phone number. And so in a relational world, you'd have to use something like null. But they always say that null is bad practice, right? Because it can mean not known, it can mean unknown, not yet known, it could be anything. And so they always suggest it's a bad idea. But the cool thing with MongoDB is that the schema is flexible. Now, if you come from a relational world, hearing that your schema is flexible might, give you a minor panic attack. Don't worry, promise it's okay. Because the great thing about a flexible schema means that some people call it schemaless, but I'd argue it at least follows a simple schema because it's JSON. JSON schema is it has to look a certain way. But it means that as your document evolves, that's okay. And it means that you don't have to, stuff missing, that's okay. So it proved really tiny, so I apologize for that. But you can see the clients, it's got an ID, property, the name, and the number of sessions, and no phone number. And it's not going to blow up. Because the schema's flexible, it can cope with the fact that there's information missing. And in a relational world, that just wouldn't happen. And that's cool. And then, just like with me, with goals and exercises, Chris has got her own goals and exercises. So the document ends up looking pretty much the same, but Chris doesn't have a phone number. And, it might be that later down the line, Chris decides to share her email address. So then that might go in there. And, Phil doesn't need my email address, so it doesn't go in. But nothing's going to blow up. It's just going to work because the schema is flexible and it can adapt as it changes, which, let's be honest, is quite important because whenever you start out on a project, let's be honest, you never start out knowing exactly what's going to be in there. Things change as it evolves. And so having it be able to evolve with you just lowers, increases developer productivity, lowers friction, and just makes your life easier. So we've touched a little bit on some of these terms, but I'll just go through them a little bit because I love this diagram that my colleague who now works at Grammarly put together. So we've seen that a row is like a document. So every row in a relational table would become a document in your collection of documents. A column has a field. So anything that's a column name in your relational table will now be a field in your collection. A table is like a collection. So rather than a table of rows, you have a collection of documents. And then a database is still a database, index still an index, etc. And we saw that joins are basically embedding. And we do support transactions, which you sometimes hear the myth that we don't support transactions. We do. That's just really out-of-date information. If you architect it and data model it right, you probably won't need transactions, but it is an option if that's something that's important to you. There we go. So the next thing I want to talk about is, well, why MongoDB? We've looked at some terms and we've kind of seen the journey I went on to kind of understand, okay, this is what it would look like in a relational table, but what would it look like in the document world? But as I said, there's lots of options. So why MongoDB? Well, MongoDB and document databases make life easier. There's high availability. So in the relational database world, right, if you want to make a change to your table, you have to, go and speak to your database admin normally, bribe them with donut, threaten them with management, something to make them take your whole database offline to make a simple change, bring it back up again. With MongoDB, doesn't matter. Because it's flexible schema, you don't have to take it all offline just to make a change. It will be there for you. Plus, if you use the cloud, which we'll come on to shortly, has high availability because it uses something called replica sets under the hood, which I won't go into too much detail because it gets a bit technical, but just think of it as a minimum of 3 nodes that form your database cluster. And so one's a primary and everything. It's called a replica set because all your data is replicated between those nodes. So if one of the nodes goes down for whatever reason, it will just promote another one to primary, and it will just keep going. So you won't see you'll see much less chances of downtime because it'll just handle it. It'll just take care of it. High availability. Then there's flexibility. As I said, the schema is flexible. So as your project evolves and your data evolves, so can your database. You shouldn't have to be held back or slowed down just because your relational database can't handle it. No need to have this big downtime. Just be flexible. Chill. And then, of course, there's vertical scaling. So This is still existent in relational database as well. So vertical scaling is this idea that if you need more resources because, I don't know, maybe you've written something that's suddenly gone, I don't know, Wordle. Wordle's a good example. Gone from not a lot to suddenly being a massive overnight hit, and suddenly all being hit way much more. And maybe your database is being, not essentially appears like it's being DDoSed because your usage increases. With vertical scaling, you just add more hardware. Might be more hard disk space, might be a better CPU, might be more RAM. But it's hard. Vertical scaling is hardware. But the problem with that is that there's a ceiling. Eventually, you either run out of hardware that exists to put in your server, or it just gets so ridiculously expensive, it's not an option anymore. And so, that's one solution, just scale vertically. And we can do that if you need to. But one thing that sets us apart from relational databases is horizontal scaling. Because of the way that relational databases work with tables and everything, they can't be split up for horizontal scaling. But that's okay, we can. If you're doing really well, you can put it in lots of different places around the world, and have it in lots of places. It's nice and available, and you can split it up in a way that works and scale outwards. One of the cool things we have as well is something called sharding. Now, sharding's not unusual if you know much about distributed databases. But, but for those that don't know, sharding is basically this idea that you pick a property on your data and you say, right, okay, use this as a reference point to break it up if there's lots of it. So if it's a huge data set, you might want to break it up. Think of it a bit like a library. In a library, they don't shove books into the library on the shelf in the order that they acquired them willy-nilly. They're broken down into shelves by author surname so that I want to find something by, I don't know, George R.R. Martin. So you will go to M for Martin and find whatever Game of Thrones book you want to find. Don't know why I picked that one. I've never even seen Game of Thrones properly. I can't concentrate on it. But yeah, so sharding's the same thing. So in a library world, your author surname would be a sharding key to break it all up. And so, you can even break it out. So if you've got a huge data set, rather than having to search through the hundreds of thousands of documents you might have, you split it up into these nice little shards and then go, oh, cool, yeah, okay, I want to find this. And so based on the sharding key, I can just go over here. It's a much smaller subset to look through, much better performance. And that's great. And we've even introduced something recently called library sharding. So if you decide, actually, do you know what? I want to change what the key is I'm sharding on in my data set. You can just go in and say, hey, I want to use a different sharding key. It will take care of switching it over in the backend for you live without you taking your data down. So again, high availability. So lots and lots of options. Then you've got readability. As I said, JSON is something that, from lots of different C family languages you'll be familiar with. And so it's nice and readable. Let's be honest, SQL and relational databases aren't really readable because you have to start doing a load of complicated SQL queries just to get the information together that you want. At least things are nicely in a document together. So I mentioned cloud, and so we're going to talk about Atlas. And by Atlas, I don't mean a map of the world, and I don't mean the God. I think this is the Rockefeller Center. No, I mean this. So don't worry if this looks a little bit small. We will see it live in a bit. But this is Atlas. So Atlas is our cloud application data platform. So it gives you all sorts of different features, all in the cloud, and taking advantage of all the benefits of the cloud, like all the auto management and scaling and lots of other amazing features. And so we can try it out. And there's lots of things in there that are great. And the cloud has the most up-to-date features anyway, compared to maybe like standalone on-prem. So Atlas is definitely worth talking about because there's so much cool stuff that it can do. And one of the things that you can do is, if it wants to work, is, ooh, I can't see my mouse, so this is it's there. It doesn't show on my laptop screen, so I'm like, yeah. But this is how you deploy a new cluster in, where's it got? Oh, look, oh. There we go. Not being able to see a mouse, it's not fun. There we go. So there's no sound on this, so don't worry. But you come in here, you can just quickly click build a database. We have a free forever shared tier called M0, which means that you can get started to play around without spending a penny, because we won't even take your credit card details. Why should we? It's none of our business if you just want to play around. And then you can pick the different cloud providers. So we support multi-cloud, multi-region deployments if you want to. So if you start to sign up to maybe a higher tier that's not shared, of course that is paid, but you can start to do multi-region and multi-cloud. So you don't have to pick which cloud provider you want. You can pick the ones that work for you and the regions that work for you, your users and your data. Then you can pick the region closest to you, and with that you can just go and start creating one. So the tier in this case is M0, which means shared and free. And then you could set the backup strategy and all that, but you can leave it as a default, and then it will just go ahead and create it for you. Now that takes a few minutes, so if we go through it, here you go. Is this going to work? Come on.
A few moments later.
There we go. So it's quite quiet. I'll turn it up a bit, but yeah, like you've got a few moments later, you'll have a cluster, and then you'll be like, okay, well, I want to play around with this stuff, but I don't have any data to do with it yet, right? What do? Well, we've got you covered. So one of the things that we've got with Atlas out of the box is if you click these ellipses here, there's a sample data set. And yeah, you just click it, it'll go ahead, and it will start to load in this, it's a few hundred megabytes, I think, of data and documents into your cluster. And so you can really start to kind of play around. And so you don't need a load of data of different shapes and kinds just to test your scenarios out. We'll just give it to you. And, again, a few moments later.
A few moments later.
Just because it's fun. I love that meme. Never gets old. But yeah, eventually you will be in a position where... Come on. There we go. Technology, eh? You can tell that no one's been in person for a while. Everything's like, you've not sacrificed the demo gods enough, come on. But yeah, once it's done, you'll be met with this screen. Don't worry too much about what's going on here, but it just gives you an idea that you'll get this idea there's been connections in the last few minutes. You'll see the input and output per second stuff. So any information that might be of interest to you is just there on the screen. You'll also be able to see things like in the bottom left, it says version, region, the tier you're on, type. So at the moment it says replica set 3 nodes, but if you choose to use sharding, then it will say sharding there instead. So stuff that's interesting to you is just there on screen, and I think that's kind of cool. But we've talked about it enough. Nope. Okay. Let's browse a little bit. So you've got this data in your come on. Yeah, so you've got this data in the cloud, right? You've got the sample data set, and this is a sample data set. But what options have you got for actually looking at the data? Because it's all well and good being given this sample data set or just having your own data. At some point, you're going to want to look at it. And so there's a few ways you can do it. The first one is in the actual Atlas UI. And there's actually something called Data Explorer. So you can actually click Browse Collections, and it will automatically take you in. So you can see here, so ignore this is stuff from before, but anything that's prefixed with sample comes from the sample data set. So you've got all sorts of different types of things that might be of interest to you. So, for example, in Airbnb, we have a listings and reviews collection in the database. And so there's loads of info here. Don't worry too much about what it says if it's quite small at the back. But you can just see from scrolling that there's lots of different information here, even fields that you can't see. There's a mixture of data types. If we go to Mflix, for example, that's got movies, and you'll see different things. There's even got an array here of genres. So there's different documents with different shapes for different purposes to really give you something to play around with. And so that's one way of doing it. And then if you go back to the database, if you want to connect later on, which we'll come on to later, you can literally click connect, and then it will give you options of how you want to connect. And we'll talk about those other options in a minute, but it'll even give you hey, here's how you do it. Or if you want to do it from an application, you say what language you're doing it in. It'll even give you a code sample of how to get started, because who wants a difficult onboarding experience? You've got to dig through a bunch of documentation, right? So Atlas is one option. We also have something called MongoDB Shell, and you'll see in a minute why I'm not showing you it. But the MongoDB Shell means that if you prefer the CLI, and some of us do, then we've got you covered. You can access your data, you can browse it, you can manipulate it, just the same as you would in Atlas. And so, like I say, if CLI is your thing, MongoDB shell is where it's at. And then we've also got something called Compass. So Compass is our GUI application, which actually has the shell built in at the bottom, which is why I didn't show you before. So this will automatically log you in because you're connected. I'm connected in the Compass application. It's here at the bottom. Probably a little bit small, but there we go. But yeah, you can see it at the bottom, so you could start to do, is it that? No, I can't. Never mind. Right. But yeah, anyway, let's zoom out again. There we go. So this is connected to the data, so you can browse it just like you did before. So you would have seen exactly the same stuff before. We've got the games database, then the samples again. So this is exactly the same database, just connected to from Compass. And the UI will look kind of familiar, right? But you can browse it, you can create collections in it, you can, go in and if you wanted to, just like in Atlas, you can insert a document if you want to. It's not just browsing, you can do the, manipulation of the data as well. And, because we've got the shell built in, it means that if you prefer to kind of mix and match a bit, and maybe you like GUI sometimes, and maybe you prefer CLI, that's okay. We've got it here. It'll connect you straight away, and you can do it in the way that works for you. And there's lots of cool stuff that you can do inside of here, like aggregations. So aggregation framework, I can literally give a whole separate talk about because it's so powerful. But essentially, it's like, it's for sort of doing things in stages, and then you can do things on the data at each stage without necessarily permanently impacting your data. So it's a bit like stages or points in like a factory. It goes on a conveyor belt. The output from the previous section is the input to the next, and you can do what you want with it. So you can start to build stages up. And that can be quite a lot to get your head around. And so we've actually got a aggregations GUI built into Compass. So if you want to start doing things, like you can select, $match. You could then say, okay, well, I want to match, this is the query I want to run on it. And so it will then find it, and then you've already filtered it out before you do the next bit. So this isn't the only way to query your data. There's much simpler ways, but in more complex scenarios where you maybe want to group things, do averages, do sums, do all sorts of different, there's at least 100 different stages, I think, that you could do to your data. But, aggregations just give you the ability to do it. And it gives you the option inside of Compass. And if you get there with the UI in terms of, okay, I can see the output of what I want to do. So, I don't know, maybe we can say that the runtime is 78. It might need to be in. Yeah. So then this filters on every movie that has a runtime of 78 minutes. So then you've already filtered it out, and then you can go, okay, well, I like this. I've got it in a way that I'm happy with. You can then just pick the language that works for you, so C#, and it'll actually give you how to do that query in your language. So if you're new to aggregations, Compass is a great way to get started. But as well as the shell and Atlas and now Compass itself, there's other ways to do it. So one of the things that we've got that I think is kind of cool is we have a VS Code extension. So you can install it from the marketplace like you would any other VS Code extension. You just search MongoDB. It'll then give you this nice little MongoDB leaf that should match my shirt. I knew I was talking today, so I deliberately picked the loudest MongoDB shirt I own. And then, yeah, we've got exactly it's the same cluster, so we've got exactly the same data as before. But what's cool is that you can do something you can see here called MongoDB Playground. So it is literally a code-based playground to play with your data. Now, this is all just the stuff that comes out of the box of the playground to give you some examples to work with. So, we're developers, most of us here, I'm sure. The word sales, that's not what we think of, right? We want something better than sales. But it gives you something to work with, and it even has comments. So, you could just delete all of this and then get started with what you want. But it just gives you a nice ground to learn from. Because, again, onboarding is really important. And so that's, but it's not just doing the playground to sort of play with the data, insert documents, manipulate it, read, whatever it is you want to do. Again, you can browse the same data. So it's a little bit small. I can always zoom in. But yeah, I just want to very briefly show you that you can see the documents, just like you would anywhere else. There's lots of options to access your data. So if we go back to PowerPoint, probably not going to be in PowerPoint about a slide, but that's okay. There we go. But 4 options to connect, right? Not bad. So now let's talk about .NET with MongoDB, right? We know that MongoDB is kind of cool and it's easier, and it takes a while to get your head around a little bit if you're used to SQL, but you know, it's still important. So we very much have a driver. So this is just a snapshot from last year of the NuGet page when you search for MongoDB. And the second one down here is our core driver, which as of last July had just short of 52 million downloads. So for a place where most people associate with SQL, right? 52 million downloads, not bad. And then at the bottom, we have our legacy Mongo C# driver. Don't use that anymore, but the reason I highlight it is that before it got replaced, it had 6.2 million downloads. So yeah, perhaps the numbers would have gone up since. So I'd say about 60 million downloads of these drivers over the years. So it very much is a consideration for .NET. But let's have a look at an example. Let's just keep it simple. Start off with a very simple ASP.NET web app that just calls to a database with some endpoints. So I like the slide because the slide deck came with these little inbuilt devices. So I stuck a screenshot in because I thought it was cool, but I know you can't see it. So we're gonna see it actually running. So we're gonna stop the slideshow again. If we hop into CLI, here we go. So we go wrong tab, that one. Here we go. So this is just a example that I wrote. I'll share the GitHub later because I actually wrote this, my first ever article I wrote. So I'm not just a developer advocate at MongoDB, I work on the content team, and so we write a lot of tutorial articles, and so I actually wrote this for our tutorial. So it's actually on our developer organization, which is kind of cool. So if we just do .NET run, it'll build, and then it should just run. Go to localhost. It will look broken because it doesn't have a front end. Because it's a web app, right? Let's just go to front end. So it's just Swagger. You know, if you've done a .NET Web API before, as long as, you know, I think Swagger comes out of the box, but if not, it's just one line, I think. And then, you know, you can just come in and try it out. So we can say execute, and that will go ahead and call API games and do a get. So then that returns all the info in the database as a JSON document. Make sure it's big enough. There we go. And then, you know, you can start to do more with it. So you could say, I don't know, very specifically get this ID and just pass it in. Oh no, let's try it out first. There we go. Fetch. And it will just get that single document. So, you know, if you just want a very simple backend, you know, you've got Swagger there to do it. But, you know, we have this working example, but how is it built, right? Well, if we come back to here, we can start to take a quick look at how this is achieved. So get past the pictures. Here we go. So it starts off with a simple game model. It's just a C# class, you know, plain old C# object, Poco. It uses some, what's the word? Not attributes, but the stuff in the brackets that you might know from, you know, other things. But it comes from our C# driver. So we're saying that this ID is going to be our ID in our database. And then we use this bson representation, bson type.object ID, because as I mentioned, MongoDB documents use object ID as a special type. And so we're just saying we want it as a string in C# because that's how we know what to use. But just, you know, take care of it for us. Make this an object ID. And it will. Then we've got, you know, the name, the price, and the category, all in data types that we know. Nice and simple. And then we have a service class that you can use. You know, it's just ASP.NET Core. It's nothing unusual. But we initialize a client, passing in the settings, get the database we want to refer to because, you know, we can have multiple databases in our cluster. And then we can get the collection that we care about. So in this case, we want to get the games collection that we stored as a name in the settings. But we've specifically typed it as a game, which means it takes care of mapping the properties to the model for you. So it's nice and easy to use. Just a few lines of code, right? Create is equally as simple. We just call insert1. So we have quite a few functions that you can call in our Mongo query language or MQL, like insert one, insert many, upsert one, upsert many, if you want to update or insert and all that stuff. And so we can insert it, and then if we want, we can choose to return the game to go, okay, cool, what's its ID and all that stuff. And we can read in one simple line. So we're just saying, give us a list of games where in that find is where you could pass a filter, which would be, I don't know, you want something specific. In our case, we don't care, we want everything back, so we're just saying games true and convert it as a list. So in one line, we've called our database, we've fetched all the games in our database, and then it's just put it into a list that we can use from our C# code. Reading one specific one, again, it's one simple line. The only difference is you're passing in the ID, and we're filtering it by the ID and just getting, going with first or default. There we go. Ooh. Go back to default. This clicker's not helping. Right. Yeah, there we go. And then update. Again, it's just as simple. We're just passing in the ID, a new game object that we want to replace it with, calling replace one, saying for that game, based on its ID, pass in this updated game, and it'll replace it. Quick, easy, simple, just the way we like it. And then, of course, you can delete by object. So you can say here, take this game object and use its ID to delete it. Or you can pass the ID instead. You've got options. Whatever works for you, works for you. But web app examples are kind of dull, right? What about something with a front end? So this example uses mflix. So mflix is that sample data that we saw. And so this is, essentially an IMDb clone. And it's just data, like I said, it's just data available in Atlas. So, what does that actually look like? So if we go, get out of our presentation again. And we go to here. Let's stop this. And then .NET run in here. Just build. We can go to it, and it will load. And what's cool is because the schema is flexible, some of these films that are super old from the 1920s don't have images, and that's okay. It doesn't blow up, it just goes, okay, image failed to load. You can just handle it if you want to, and if not, it's just, okay, it's not there. And then you can go in and you can do different things on it. And what's cool as well, as we'll see later on in another example I want to show you, is that we can do searches. So Atlas has something called Atlas Search, which is built off Apache Lucene's engine. So you can do full text search from your data, if you like, out of your Atlas cluster. You don't have to spin up a separate thing. You just enable an Atlas Search. So, it just matches anything with Potter. So we've got Harry Potter, we've got the story, I think that's about Beatrix Potter, and it's all there. But that's just using the sample data. But what's cool about this is that it's not just any old demo. If we play from current slide, there we go. If you want to make that same program, you can. This is actually made using a course on MongoDB University. So if you're thinking, okay, this is kind of cool, and I've heard some things I like, but I want to, be guided through it a little bit more, and maybe a mixture of not just beginner stuff, but everything up to really advanced. Well, the university can help you. And that mflix sample that you just saw, I actually made following a MongoDB University class. So MongoDB University is a completely free learning resource. So you can log in, create an account. You can do everything from the very, very basics of M001 class all the way up to more advanced. And it's a mixture of recorded videos, interactive labs, and quizzes. So you can really get hands-on and learn this stuff. And so I made that sample using M220N is a class that I took. Don't worry, there's links later, so you don't have to remember that. But, it's just super cool. And I think the UI's had a refresh since I took this picture, but, the idea is still the same. There's even, the N in M220N is because it's .NET. So if you want to try it in JavaScript or possibly even Python and some other languages, it's an option. And so now I want to talk about Realm. So as .NET developers, we sometimes make mobile apps, right? I know me personally, I'm a Xamarin developer at heart, even though I do it on the side and very rarely. And so when it comes to data on the mobile, that's a concern for me as well. And so Realm is our mobile database offering. And it's actually more than just a mobile database, but the thing that most people think of is our mobile database. So it will give you a local database on your device. So if you're going offline, that's all right. The data will still be there because you've got a database on your phone, which, we've all seen the spinny circle or the Twitter thing fail to load timeline because Twitter's a bit different, there's so much data, but yeah, you don't want to be losing users on your app because they've gone, oh, I've lost signal and now my app doesn't work properly. Yeah, install, I'm done. So, you can have it on the phone, and then you can enable very simply the tick of a box something called Realm Sync, which takes care of online-offline sync. So if you're offline, it will still work. When you go online again, it will update everything, and it points to an Atlas cluster. So if you're maybe making an app version of a project that already exists, and you've got a database already, you don't need to make a new one for your mobile app. Just point it to the same one. And because Sync's there with you holding your hand, if you go offline, as soon as the user comes online again, the data just gets synced to Atlas. And you can decide whether Atlas data takes priority or the local database takes priority, and whichever one is, it'll keep it in sync for you. But we've got other features as well as part of our application development services. So we've got authentication, so you can do anonymous login, email and password. The big social providers like Google, Microsoft, Facebook, Apple ID, all that stuff. We've got functions. If you like serverless stuff, you can do functions. We've got triggers. So you might want to say, oh, I don't know, when an app's running and someone logs in for the first time, create a user document for them. So a trigger will say, OK, a new document's to be created, and then the function will go ahead and handle it. And then we've got schemas and data access rules. So I mentioned earlier that MongoDB schemas are flexible. That's true. But if you want a schema, you can have one. So, if you decide, OK, we want the data to be rigid, we know what it looks like now, we can set up a schema, and it will do validation for you. So if people try and insert anything they shouldn't, they'll be told. Let's click it doesn't like me. All right. And so I'll also show you a quick demo. So Realm has a getting started tutorial online, and it's in multiple languages and platforms, not just mobile. So you can do the back-end side, which will create the bits you need in Atlas, and then you can start to the front end. So in this case, this is a mobile task tracker, because I'm a mobile developer at heart. Like I say, it's a bit of fun. So if we open the iPhone simulator in here's what I prepared earlier, Blue Peter moment. Ah, PowerPoint does this. There we go. Now you should be able to see it. There we go. So ignore that the font's terrible. I didn't make the UI on this, but it has log out at the top right, manage my team, which are clickable, and then you've got like my project, and it pulls the data in. So we can see that I've already got a task in progress, right? Called give a great talk at NDC London. Well, we can say that it's not open anymore. It's in progress. And hopefully by the time we're done, at least one of you will think I should change it to complete. But you've got it there, and then you can add new things. You can manage your teams. You can have members, so multiple people can see the same lists. It's nothing fancy, right? But it's just a cool way of getting to know how you might do certain scenarios with MongoDB and Realm and all that stuff. And as I said, it was built using the Getting Started tutorial. So if you want to try it yourself, the code is out there, and so is the tutorial. So that's kind of cool. So that's some examples. But let's just talk about it in action a little bit, because, like I say, they're very high-level intro kind of samples. But come on, Luce, tell us some cool stories about where this is used. So this is a game written in Unity by a colleague of mine, and it's using Realm, I think, in the back end to store the high score, so that if you spend ages playing this space shooter game and do really well, next time you open it, it's actually going to remember that you did really well. And so that's cool. We can game with it. The same colleague also made a game for AWS reInvent last year. And so, yep, that is right. That is me. I am in a computer game. So this was written again using Unity with MongoDB in the back end. What my colleague did is he put characters of all of us in the game, and people at the booth at AWS reInvent could pop around and speak to different characters and learn more about MongoDB. And there was even mini games with fishing, I think it was. But so gaming's an option. And if you're interested in how this was made, later on I do actually share where you can go and find the code for this, which I think is kind of cool. But let's just have a quick look at some more examples. So let's go in to my browser. And so let's go, hang on, let's get out of PowerPoint so I can see my mouse again. Hopefully. There we go. So this one's quite like, not boring, but a bit more serious. COVID's not gone away. So Department for Work and Pensions, the government department that deals with, benefits and everything, actually runs on MongoDB Atlas. And so when the COVID started and so many more people were furloughed or made unemployed and needed a bunch of help, with universal credit, demand was huge. Now, I can't speak for universal credit because I know that some people have had issues, but it wasn't because of us. We were able to scale to meet the 10 times demand. Like I said, scaling, vertical, horizontal, we can handle it. And because it's all in Atlas in the cloud, it's managed for you, which means that it just adapted. Like I said, it may not be the most exciting, but I just think it's an important one because in a world where you've just lost your job and you really need some help, especially at the moment with the cost of living crisis and more people needing help than ever, I think it's nice to know that there's things are out there using MongoDB that are there to help you. We've also got this interesting article about how some different industries are using MongoDB. I'm not going to sort of read through it all with you now, but it's just talking about it, and then talking about Bosch, for example. So they use it for some of their Internet of Things stuff. So sensors, time series data, all that stuff is an option. Yeah, so IoT data and all that stuff, data management and all sorts of things. We've also got this one. So this is an article. Again, all the links are shared later, so if anyone actually wants to read more about these or watch the videos, they can. But basically, Toyota, somewhere in Europe, have a smart factory with robot forklift trucks, basically. And MongoDB Atlas is used to store the information and all the sensor data coming in from these forklift trucks so that they could move around more easily. And they, as you see here, talking about how they moved from monolith to microservices with Azure and Atlas. So, you saw that we support the main 3 cloud providers. That includes Azure, and so they, that's what Toyota are using. And so, that's great, and it's just another example of how it could be used. And then in a complete turn to another area, we've got gaming. So this is talking about Sega Hardlight. So Sega Hardlight is a mobile game studio based up in Cheshire, I think it is. And a few years ago now, they switched to using MongoDB Atlas for everything that they do with games. So every Sega mobile game you might have played, from Sonic Rush to Crazy Taxi to more, uses MongoDB under the hood. There are some other big name examples, like one of the world's largest multiplayer online games, but I'm not allowed to say what it is. But just take it from me, it's huge. And so, mobile games as well. There's also, banking and all sorts of things. We've got security out of the box. We have things like field level encryption as well on all your information. So even banks trust us for their information. So that's kind of cool. Now, as I mentioned, the code for my friend's thing is available. So if we have a look here, no, not that one, that one. So this is our MongoDB. Let me just make sure that this is, public. So this is our developer relations GitHub repo. So you can literally come in and find demo samples in a variety of languages, frameworks, tools, different things that we've put together to help you. So for example, if you search AWS, it will bring up that reInvent game demo. So that one that you saw me in, the code is there for you to have a look at. So if you're interested in how it was put together, there's literally a video. And one thing we do try and get right is to actually put half-decent documentation in to help you get started. So there's a quick guide there as well. And then Adrian's here, I think. And then we've got another one, which is a restaurant finder. So this is using the restaurant sample data. It's a whole thing. You've got the Atlas search built in. You can filter. If you're interested in how a search is put together, you can literally click the box, and as you do it, it'll do it. So I don't know, burger, and you'll actually see the query it will do. So if you're interested in how something works under the hood, this actually gives you ability to have a look. And this is just Restaurant Finder. I'll make sure the link is in the links at the end. But yeah, you can actually start to have a look at how it was done. And then there's other bits that's going on, like faceted search and stuff that you might do. So you can, let's not zoom in on the Lincoln Tunnel. But it's just another example of demos that have been put together by the team, just to give you an idea of how stuff can be put together. As I said, we've got the whole repo. So if you do want to have a proper look at more examples, it's all there. So that's pretty cool. So let's go back to here. There's lots of examples, and it's cool, but we can only fit so many in, right? I wanted to make sure there's time for questions, because I think I gave this talk at a user group in Liverpool back in January, and I think I was being grilled for 25 minutes. I didn't mind, it was okay. But yeah, people tend to have a lot of questions, so I try and leave a good few minutes in for people to ask me questions. So we've seen quite a lot. We've seen, well, what document databases are, the terms and how you map them, and don't worry, the slides are also available. So if you want to go back and look at like that term mapping diagram, you can. What MongoDB Atlas is, what MongoDB is, including Atlas and Realm. Now, as if you do anything with .NET and Microsoft Azure, you might have seen in something like the Azure portal that you can create a MongoDB Cosmos DB. Don't. It's not meant to be controversial. They're not directly partnered with us, so it's not the latest version of MongoDB Atlas that you're using. And I think we have a website that does compatibility tests. I think it's at something like 40-something% on the tests passing. So yeah, absolutely. If you want to use MongoDB in the cloud, use Atlas and just put it on Azure. We take care of the payments. You don't have to do it separately. You can either use a free tier and we pay for it, or if you do pay us for our cluster tiers, it's very, very affordable. And they will just pay Azure, so you don't even have to, but it's just much better. Heard about Realm? Oh.
Attention please, attention please.
Wow.
A fire has been reported within the building.
Oh, great.
Please leave the building immediately by the nearest exit.
Well, I'm just going to quickly skip this bit.
But leave the building by the nearest stairway.